So today we're going to go through our last installment of week 6. So by now you should have the week 6 packet out in front of you. So we're going through 11 through 15 today. All right, 11, and I'm going to stack up. Oh, it's on the back side. Okay. So 11, according to figure 2, so I'm going to look at figure 2. From 4 hours to 7 hours after oral administration, formulation A. So go to figure 2, that's this one. 4 hours to 7 hours. So I'm looking at this window. 7 is right here. Okay, and then I'm looking at formulation A. So I need to find my formulation A. It does this. So there's like a flat line, but a slight increase and then a decrease. But for the most part, what does that do? That's basically just decreasing only. And there you go. Okay. Based on figure 2, that's where I'm looking. During the total time in which formulation Z's drug concentration increased, formulation Y did what? So let's find formulation Z. That's the triangle. So the total time that it increased, which is here to here, what did formulation Y do? So formulation Y increased, then decreased, right? Increased and decreased. So the answer to this one is increased and decreased. Beautiful. Okay. Probably done with that page. All right, 13. So, according to the data in table 1, so I'm going to look at table 1. If the masses of the carts remain constant, as initial velocity increases, final velocity does what? So let's go to table 1, and then let's look at all our variables, okay? So the masses of the carts remained constant. So that means I'm only going to be looking at the 2's, or I'm only going to be looking at the 4's. As the initial velocity increases, okay, so these are actually split trials right here. As this increases, okay, what does the final velocity do? That went from 1.5 to 3. That went from 1 to 2. Okay, 3.4 to 6, 2.2 to 3.9. So within those constants, that's all increasing as well. Right? So, for 13, we're looking at A, increases. And remember, because it didn't say like, you're not looking, so the distractor answer would have been if you looked at this whole trend, like, oh, it went from 3 to 6, so this increases, and 1.5 to 3.9. You actually probably still could have gotten the same answer, but it wouldn't be exactly correct because you wanted it when these stay the same, right? So only within the trials where the masses don't change. All right, 14. Based on the data in table 1, so we're going to look at that page again. As M2 becomes larger in relation to M1, VF does what? So, as M2 becomes larger, what does the final velocity do? So that means that it goes from 1.5 to 2.9. So that means the final velocity is like between these two. So we'll say, I don't know, 2-ish. That's going to be 1-ish if we're taking the average, 2 to 4. That's going to be 3-ish, okay? Because it's looking for what's happening to the final velocity as these numbers change, okay? So 2.9 to 2 to 3.9 and 1.5 to 1.1 to 2.2. So, for question 14, yeah, well, let's see. 1.5 to 2.9. Oh, this is actually, we don't need to look at this. So, because it says increases. So we can cross this off for that question because this is the only time that V2 gets big, or M2 gets bigger. So 2-ish to 1-ish, that's a decrease. So the answer to 14 is B. And last step is 15. According to the data in table 2, so I'm going to look at table 2. Which of the following best describes changes in V1 as VO increases when the masses of the carts are equal? So that means that for this question, I can cross off this trial and cross off this trial because these aren't equal masses. So equal, equal. Okay, so we'll describe the change in V1 as V naught increases and V1 remains the same. So the answer is C. And that's all. Congrats on finishing one more week.